Okay guys, so we're going to continue with some problems for Gibbs free energy, delta G equals delta H minus T delta S. And so here's another example, a different kind of example, more complicated, but it's still not overly difficult to solve. And so given this reaction, NH4 ammonium nitrate, we're adding it to water, and so really all we're doing is we're dissolving the ammonium nitrate. So the ammonium becomes dissolvated and the nitrate becomes solvated. No necessary reaction with the water per se. The water is just surrounding the ammonium and the nitrate. So here are conditions that are given. It's at 25, and here are the heats of formation for the ammonium nitrate, the solvated ammonium ions and nitrate ions, and here's the enthalpies for those as well. And so to plug into our delta G equals delta H minus T delta S, you're going to have to calculate with this data the delta H and the delta S before you can plug in to the equations. Now, given the enthalpies of formation, hopefully you remember that the enthalpy of reaction, if you know the enthalpies of formation, is the sum of the enthalpies of formation of the products minus the sum of the enthalpies of formation of the reactants. Okay, and so if we use that, the products are the ammonium and the nitrate, and so the enthalpy of formation of the solvated ammonium is negative 133 plus the nitrate is negative 205. So that's the sum of the products minus the reactant, which is going to be negative 366. All of these being kilojoules per mole. And so when you add up these, you get 28 kilojoules per mole. That being the delta H. So delta H equals, once again, positive 28 kilojoules per mole. Now, delta S can be determined the same way. Delta S can be the sum of the enthalpies of the products minus the sum of the enthalpies of the reactants. And so once again, our products are going to be the ammonium and the nitrate. So positive 113 plus positive 146. And then we're going to subtract the reactants, which is the positive 151. Add up those, and you're going to get positive 108 joules per mole Kelvin. So delta S equals positive 108 joules per mole Kelvin. And now we can plug into our delta G equals delta H minus T delta S. And so the delta H is positive 28, so 28 kilojoules per mole, minus the temperature in Kelvin, so 25 degrees in Kelvin would be 298, multiplied by the delta S. Now remember, the delta S is in joules. We need to convert it to kilojoules, so this will be 0.108 kilojoules. So 0.108 kilojoules per mole Kelvin. The Kelvin and the temperature cancels the Kelvin, giving you kilojoules per mole, which can add to kilojoules per mole. Multiply this and then add these together, and you get a negative 4.2 kilojoules per mole. Okay, which tells you this is spontaneous. That ammonium nitrate will spontaneously dissolve in water. So this is just another method. It's going to just incorporate some of what you've already done into the delta G equation. I'm not always going to give you the answer of delta H and delta S. You're going to have to calculate those. You could have to calculate delta H with any of the techniques we've used. Hess's law, Hess's cycle, any of that stuff. The sum minus the reactants, any of those techniques could be used to calculate delta H. And then we also had a couple of techniques for delta S. So one more example. Okay, so what is the delta G for the combustion of methane given the following delta G of formations? And it gives you the delta G of formation for methane, carbon dioxide, and water. Notice we're lacking oxygen, and we talked about this with enthalpies. If I'm going to make oxygen from the formation is to make a substance from its elements, there's no delta G here. So the delta G for oxygen is 0, so we can ignore that one. So this is very much like previous that we did for enthalpy and then also for entropy. If you know the Gibbs free energy of formation, then the change in Gibbs free energy is going to be equal to the sum of the change in Gibbs energy of formation for the products minus the sum of the change in Gibbs free energy of formation of the reactants. And so all three, enthalpy, entropy, and Gibbs free energy can be solved with this technique if it's the enthalpy of formation, entropy of formation, Gibbs free energy of formation, if those are the values that you have. So just plugging in, we're going to have CO2, so that's going to be negative 394 plus, now we do have two waters, so we're going to do the water times 2, so 2 times negative 237, and then we're going to subtract the reactants, which oxygen is 0, so we're going to ignore that, and methane is negative 51, all of these being kilojoules per mole. Okay, add those up, and you'll get negative 817 kilojoules per mole. Once again, negative Gibbs free energy means this is going to be a spontaneous reaction. So those are two additional methods of calculating Gibbs free energy.